This is a standard odd-even implementation. If we run this code now, we get the result. But can we go faster? By eliminating if statements, we can save on some performance. Let's run this. As you can see, it behaves the same because it returns 0 if it's divisible and the rest if it's not. But we can go even faster. By rewriting the code in a compiled language like C, we can make the code run even faster. Let's build this. Ignore the warnings, and it's faster. Tip number 1. Always indicate types when creating a variable. Tip number 2. When creating a function, always use types. Always use descriptive variable names that tell exactly what is a variable, why is there. When dealing with larger if statements, break it down into variables with descriptive names so the reader knows why it's there, why the if statement looks like this and why it's for. Comments should be used to explain why something is there and not how it works. The code should be readable enough to be able to speak for itself. Comments should be used only to describe why the function or why the code snippet is there in the first place. When dealing with classes, make sure to provide the parentheses if function is an object to make it more readable, and make sure to type things correctly. Indent functions by one space, so like make a space before the function, not clutter, it's ugly. And remember to use the result variable and return it later so it's readable. These are some best debugging practices I could have come up with. Use the print function. When you have a problem, it's likely that that print function is going to solve it. Use descriptive messages. Should include the line number, variables necessary for the section, possibly some conditions if necessary. If in loop, recursing or like try capturing the iteration number and the data that is passed. Make sure to correctly assemble logic, so like you don't do like a banner when you don't fuck up the logic. Like, for example, not putting enough parentheses and doing the and it fucks up the logic. Or you can use a debugger. which I don't have experience since I'm not a soy dev. And let's go on to some examples using Python, shall we? Okay, so this is not so great way to do it. In smaller projects it's acceptable, but when dealing with serious projects I'd more likely to write this. It provides more information about the line and helps us come up with the error and the unexpected behavior faster. Also, we here have the type annotation, which is optional, but it provides the developer more data on the variable. Also here, when dealing with if statements, make sure to make the condition clean and make sure to split the condition parts into separate print statements, so you have the better view of it. And here you just have the final output, and that's bad because you'd have to make too many calculations in your brain just to process that, and they might be incorrect. So this is a better approach of debugging, just writing clean code, and when you fucked up you can write some more clean code to solve this problem. Be sure to correctly assemble logic. In the previous example, this if statement and this one, this one's wrong because it's incorrectly assembled logic, but this will run because we fixed the logic. Make sure that the math is okay. When it comes to while loops or any other type of loop, including recursion, you should include in your debug message the iteration number, so it's more clear. Also, you should include values that might change the control flow of the program. When it's dealing to recursion, you can just pass the iteration number as a new argument, and when doing recursion, just increment it by 1.
Fuck you.
Okay, so today we're going to be implementing this problem, solving it with Python. Let's make our function. Let's call it just P1 because that's the first problem. It has no arguments, and let it return the sum, so integer. And now we must do for the number, so for number in range from 1 to 1,000. We're gonna find the sum of all the multiples of 5 or 3. So if number divisible by 3 is 0, or number divisible by 5 is 0. We want to add it to the sum, so let's make our result variable and it has 0. We're going to return it. We're going to return it, and I really hate this, so let's just make a condition. So diff3 divisible diff3 bool is equals to boom, diff5 bool is equals to boom, and now change the value. And now if diff3 or diff5 or diff5, then we want to append it to this result plus equals number. Okay, that's our function, and let's do this. Let's make actually a function main that returns nothing, and the P1 instance, let's call it like that, and it's going to be an integer with P1. And now print the P1. Print the P1 instance. And now if name is equals to main, we're ensuring that our script is run as the main script, and now we execute this function. Let's do this. So apparently this is the sum. Where's the answer? If we list I show the problem content, where are the answers? Wait, project Euler R1 and so 233168. Well, that appears to be true, so thank you for the episode. I might do another one of solving the Project Euler. Heck, I might actually do a stream. Let's go. We did it. The topic of this video was chosen by you in this post. So basically, this library has two functions, add and sub, which adds and subtracts numbers from each other. Another file we have here is the C implementation, and this gets compiled into lib.exe later. And we have the function wrapper, which basically just returns the value that the program returns. So let's see it. I'm going to cd into the lib now and compile the libc, just so I don't get suspected of anything. Okay, let me cd out and use .py. So the file basically calls the application it calls the application written in C that basically has like two modes, and here is the library in C. If is add, then result is equals to a plus b. If subtract, result is equals to a minus b, and then return the result. So basically that's how it works, and the opportunities with this are pretty much limitless. I think that NumPy is written like that. NumPy is written in C. Pygame is as written in C with the Python wrapper. It's just a wrapper for SDL. So you can see it's being useful. Okay, so that was the video. If you want to participate in votings for topics of the new videos, see my community tab, and goodbye. Okay, you ask, so I shall deliver. This is a polyglot code style game written in C and Python. Well, technically it's written in Python, but it counts because it's like a C file that both is runnable by the C compiler and the Python interpreter. Let's just see. So Python flatbird.py.c, and we've got the beautiful bird here. Yeah, I actually made that bird, don't judge me. When the pipe goes out of view, it counts as a point. It randomly generates pipes based on 3 positions, but it can't, I'm waiting for it to generate pipe. Oh, I must have touched the pipe. No, faster, I don't have, oh, you see, another position. There is one in the middle, maybe I can get that one. Oh, this is maybe this, I don't, oh, and there is one on top. Okay, so this is basically the game, and now if I touch any of the pipes or ground, I die. So let's run the C version, gcc flatbird.py.c, and it compiled into a.exe. Let's run the A, and it's just basically like a launcher for the Python code. I'm sorry, I didn't have enough time and patience to create a game in Raylib because I would have to learn how to install C libraries, and I don't want to go insane. So this is basically the game. Here is the Python code, and if you watch my last video on Polyglot Hello World, you should know how this works. I redirected to you, and I just want to say that further game dev questions and challenges for game dev will be denied, because I don't want to shift the direction this channel is going from general programming into game dev. I hope you understand me. I just want to make the channel about programming and no game dev. Like, I might add some game dev, but this channel is about programming and will be about programming. So, thank you for watching. See you in the next one. The genius mind behind the transistor. Transistor is a piece of electronics that blocks the flow of electricity until a smaller amount of electricity is provided. Then it allows the main current to flow. Here you can see on this beautiful animation that it took me months to make. So it basically is an AND gate. It has the same behavior like an AND gate. Basically 2 to be on, then the output is on. The transistor was made in December, in 23rd December of 1947 at Bell Labs by William Shockley, John Burdin, Walter Britton, and it looked like this. Compared to the current transistors used in processors, it's fucking enormous. Here you can see the inside of the silicon chip of the processor. See these colors? Every single one of these, smaller even than a pixel, because I couldn't fit it, smaller than a pixel piece, is a transistor, nanotransistor. Yeah, they contains billions of nanotransistors. If you can't read these, I'm talking about European billion. But why are they so important? They power the whole computer. The processor is like the brain and heart of a PC. It can compute almost anything when wired the right way. Heck, even this video runs on the CPU. The CPU is constantly computing. It's constantly computing this video. So thank you for watching. Mind leaving a like. See ya later. This is why you should not learn C++. Beautiful error messages. Look at this. Why? With object declaration. Like, what the hell is this? Public, private, and semicolon. The colon. Syntax sugar. Here you can see 3 different methods to do the same problem, which are weird. Like, what the hell is with that for loop in the right corner? Even more syntax sugar. Just look at the if statement at the right. What is this? Yeah. Intuitive lambdas. That was ironic. They are not intuitive. Why you declare a lambda with the square brackets? Why? Like the rest I can understand, the int a and b, and then the body, and then the return. I actually like that you get the body instead of like a specific value. But what's up with this square brackets? Why are they there? And what the hell is with this type? Standard function int, int, int. What the hell? C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. That is true. In C, there is very much room for mistake, but in C++, when you actually do a mistake, it's really harder to debug, and you might actually want to start over your project than debug these error messages. There are too many ways to solve the same problem. This can lead to different code across the code base, which can make it more unreadable and uglier. Yes, that's what I mentioned with the syntax sugar. So thank you for watching. These are the reasons why you should not learn C++. If you want me to make a video why you should learn C++, then leave a like. Today you're going to actually learn how to center a div. First off, let's get our center tag. Let's create a div and put in our text. Let's refresh the page, and here you can see center div. Thank you for watching. See you in the next one. This language has the potential to replace C. When it comes to level of abstraction, it's above assembly and under C. It's faster, slightly faster than C. Something like that, slightly faster. Here you can see comparison of the Hello World program in the three languages. As you can see, assembly provides little to no abstraction. Zig provides medium abstraction, and C provides some more abstraction. Zig has a built-in testing API. Here you can see the test. Zig is fully capable with existing C++ code bases. That's a cool feature. You can see here Raylib being imported and used. That's cool. In Zig, the memory allocation is easier than in C. You can see here allocate of type U8, 100 bits or bytes, whatever is that. Defer, allocator free memory is going to, at the end of the scope, just deallocate and free the memory. That's very cool. For loops don't exist. They are just while loops with the comma operator and the action in parentheses. Here you can see the example FizzBuzz program. And thank you for watching. Goodbye. should you learn, Fortran or C? Both languages are general purpose. They are mid-level, providing a mid-level abstraction, but some claim that Fortran is simpler than C, so I'm going to put it slightly upper in the mid-tier. Fortran was developed in the 50s because John Backus was tired of writing assembly, while C was made by Dennis Ritchie in the 70s. Fortran is used for heavy mathematical computing, and C is used for almost everything. So they are both compiled and they are both pretty goddamn fast, and the speed is almost like pretty much the same. So for C I'd use GCC, and for Fortran GFortran. Those are the best compilers, CLI tools. And if you think any other than, I don't know, maybe you should learn these tools, they are the best. And onto the flaws. C doesn't have any flaws except for manual memory management if you are a soy boy. And it comes to Fortran, variables must be declared at the start of the program. This is kinda whack, not gonna lie. Strings are whack. They are characters with a length of the length, and I'm going just to say that the syntax to declare strings is pretty goddamn weird. Functions are programs. Yeah, that's what they call it. Implicit none. If you don't know what implicit none means, basically Fortran decided that any variable that starts with I, J and K is an integer. So implicit none just disables that, and I don't even know why this feature is in the first place. The print star function command, whatever you call it, indents one space. This is hella ugly. And with consideration of those facts, which one should you learn? And the answer is you should learn C. Goodbye.
Huh?
So this program apparently runs in 3 languages. Let's try it. GCC hello world.py.c output AXA A. Okay. Now let's try it with G++. Still works. Python hello world.py.c. And how does it work? So this is how C sees it. Include the standard library. This is basically a command. We define a multi-line command, which is our function Python command. Now we define the hello world, and this is just int main blah blah blah. And we're calling the function. And how Python sees that? Python sees that like this. this is ignored, this is a function, this is ignored, this is ignored, and we call a function. So that's how Python sees that. Okay, so pretty much how to design a programming language. Here now on the screen you can see the Hello World example. It's basically cout. It looks like cout. Shut up! It's beautiful. Now you can see the variable input example, which just prints the input of the we gave and saves it to variable, same stuff. Now you can see how the functions are defined, and if you catch the drift, that you can now see that in the names of variables you can have spaces and characters since they are just strings. So that's how the function looks. It's pretty cool, not gonna lie. Now you can see the if statements that like basically work the same. Not gonna lie, they work the same. Now you can see a loop example. The reason I don't add like while loops and the for loop for each loop is because I like freedom and I like to specify the loop myself. So that's why it isn't totally an excuse for me to add more features when I will be implementing this language, if I will be implementing this language, hopefully not. Now you can see how you can create a module, which is basically a file, and all between the module and the end module will be added to the file before passing it. That's pretty much how it's going to work. And now we can see how to use and import the library, the module you created. Yeah, if you like enjoyed, have anything to say about the language, or you want me to try to make it actually work, you can comment down below. Thanks for watching. Join my Discord server. There is pretty much only cool people allowed, so join my Discord server and see you in the next one. So, jQuery 4 has just gone beta. Firstly, IE 10 and older are no longer supported. It's not like somebody used them in this time, like nobody uses IE anymore. And these deprecated APIs listed here on the screen got removed alongside push, sort, and slice. And there's this thing, something about ordering, which I'm too smart to comprehend. Yeah. They also migrated from AMD to ES modules, whatever the fuck that means. And that's pretty much it when it comes to the update. Note that it's still in beta, and yeah, nobody uses jQuery anymore. Bye. Okay, this project made assembly like 10x better. If you don't know already, I'm talking about construct.
made by the YouTuber CodeNibble. It provides some basic abstraction without sacrificing any performance. Currently, it works only for Linux, so I cannot try it. But let me take an example from the GitHub repo. If you ever saw assembly, you would know that this is brilliant. It provides with better function syntax, if statements, and while loops. Thanks for watching, consider subscribing and go on to my community tab. ChatGPT is an AI chatbox thing. When it comes to us programmers, ChatGPT might be a savior, but when it comes to programming, it is stupid as fuck that even a 4-year-old can do better. Trying to get it to allocate memory in C is effing impossible. And heck, even for languages as simple as Python, it makes up modules and functions that don't even exist. In conclusion, ChatGPT's greatest weakness is writing something it is made from. How ironic is that? Thanks for watching, consider subscribing and go on to my community tab. For years, Python has been the language of choice for beginners learning how to code. It provides users with almost English-like syntax and is highly featureful. Personally, I used Python for like 4 years now. However, the issues that Python brings to the table alongside its features and rich developer experience cannot be ignored. Ignoring the fact that Python is slower than most languages, there are more important flaws of the language to consider. First being that the variable assignment is the same as variable declaration. The beginners watching might ask, isn't that the same?
No, God! No, God, please, no! 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 No!
Let's vent to see for an example. First, we declare a variable, binding it to current scope until its thread. Then, we assign and modify its value. With this approach, we have the full control of where our variable is able to be used. On the other hand, Python does not provide us with that freedom, instead managing it on its own, which can lead to runtime errors. The way that developers fix that is by making a class to hold all global data instead. It's better that we change that. By introducing the let keyword, we could manage it on our own without sacrificing the Python's simplicity. Second and more important flaw of Python are the constants. You can indicate that you want the variable to be a constant by typing its name in all caps. But the Python interpreter doesn't force immutability on said variable. To fix this alongside the let keyword, there could be also the const keyword. The next issue might be personal, but it's worth saying anyway. Deranged indexing in Python is weird. It's a good feature, but it's poorly designed. Why does the first border index get included but the last border one doesn't? And the same is with the built-in range function. Like why? Another one is the for loop. I understand It's intuitive and practical, but as a for each loop, not for. For loops rely on a concept where you set the variable up. You set the breaking condition. You tell it what to do each cycle. That's why I think that Python should have renamed the for loop into for each. And there should be an actual for loop instead. Maybe looking something like that. Last one is the lack of increment and decrement operators. Okay, hear me out. I know that the same thing can be achieved by plus equals 1, but the increment operator is way cleaner. Isn't Zen-like syntax all Python is about? Thanks for watching, consider subscribing and go on to my community tab. So, I made a simple calculator program from scratch in C. First, we include these libraries. Our program starts with an infinite loop, which is the body of the program. We take the operator as an input into char operator. Then we take two floats into num_a and num_b. Lastly, based on the values, we set the result and print it out. Thanks for watching, consider subscribing and go on to my community tab. Edge is a browser pushed down our throats by the amazing company of Microsoft. Oh gosh, how much we love Microsoft, don't we? Alongside with Chrome, it is an absolute memory hog. While Chrome is stealing your data for Google, Edge does the same but for Microsoft. It contains so many features that it could be an OS on its own. I'm waiting for the day that Microsoft makes Edge OS a thing. Edge and Chrome are pretty much the same, and the reason why people tend to use Chrome over Edge is because they want to have choice. They want to have the freedom to choose whatever the fuck they want to use. They want to have the freedom to do whatever they want on their machine that they bought with their hard-earned money, and not to follow like some code from a company that doesn't really know what they want. But throwing the moral problems of Edge aside and how Microsoft is pushing it down our throats, Edge is pretty much as bad as Chrome. Uses the same amounts of memory, so pretty much you're gonna have to buy another stick. It also uses very much CPU. It's like also a performance hog like Chrome, but it's more of a performance hog than Chrome because each like extension is a thread, and when you have a lot of extensions, it just fucks your computer in the ass, not gonna lie. Lastly, people use Chrome because they like choice, and that's pretty much obvious because I tagged it in the last fucking minute. Fuck Microsoft, fuck you Edge, although I use you because I like have no fucking choice when it comes to the browser. When I search for something and I accidentally web search, then Edge comes up, and I don't know how, since I uninstalled it like a million fucking times. So yeah, fuck you Microsoft, go fuck yourself, I don't know. You should consider giving us freedom with the OS we bought for our machine. And yeah, remove your bloatware from Windows because it would be a good OS without your bloatware. Yeah, goodbye. Sorry for swearing again. Why indexes start at 0 and not 1? It is because back in the dark ages of assembly, there were no such things as predefined types, int, floats, and etc. The way that developers could represent arrays was a long snippet of bytes of the same type combined from its elements. So let's say we have an int array of 4 elements, 0, 2, 4, and 8. In C, we would declare the array as int array is equal to 0, 2, 4, and 8. In assembly, we would do array db 0, 2, 4, and 8, and the computer would store it as so, which is just all the numbers converted into binary that are mushed close together. When dealing with arrays, to get the value at a specific index, programmers would use the formula memory address of the array plus the length of a type, in int's case 32 bits, times the index. With the index of 0, you would get the array's memory address, aka the first element address. Now, by looking 31 bits ahead, we would have the full integer. That's why the indexes start at 0. And also you might ask, what about the languages that use 1 instead? They are wrong.
So, in today's video, we're going to be taking a dive in the Wolfenstein 3D renderer and how it works. Computers back in the day were primitive and couldn't do 3D. The engine used raycasting, which is basically writing lines onto the screen to get the field of view. So, in reality, the Wolfenstein 3D is a 2D game that gives the perception of being 3D. Thanks for watching, and make sure to check the community tab on my channel.
Just a quick update about my TI code editor project. I made a function and it works perfectly fine. Just as intended? Hell nah. I won't be recording videos on this project, like I will make one big video instead once I'm done with it. And yeah, that's pretty much it from the quick update. Join my Discord and goodbye. Okay guys, hello. Today I feel better than yesterday, so that's a plus. And I feel like I'm closer to making the function that I need to finish the major part of my TI code editor. Yeah, I'm trying to pretty much snap the text to the terminal size, you know what I mean, so it doesn't involve the scroll button, the scroll wheel, and I feel like I'm close to solving that, but I still have some issues. So if you might know how to do it, I don't know, join my Discord server so you could help me. Yes, that's pretty much it. I added a line counter and a position counter like in Vim, but it's on the top instead on the bottom. Now I'm going to play back a simple like hello world or something. Yeah. So that's pretty much it from the quick update. I will make a major video on it when it's actually working, but it's quite hard to get it working. Yeah, see you in the next one. Hi, hello, and welcome. Today we're going to be talking about the progress on my Vim-like editor. If you didn't know, I announced it in one of my videos, the episode 1 of the series, and I developed the first section, which is the text input area, and that's pretty cool. Yeah, also I decided to switch this project to C++ since it's working better with strings than C. And yeah, that's pretty much why I switched to C++. The GitHub code will be in the description, and without further ado, here is how the editor works so far. Okay, so you have voted for me to make a TUI code editor in C. I'm not gonna lie, it is an advanced project. So today we're going to plan this thing out. First, we need to make a text input. I think I'm going to use getChar and try to resize the string dynamically. Second, we try to implement saving and opening. Third, we'll make some code highlighting, mainly for Python and C, since I use them the most. And lastly, we'll make some commands that can be written when you access the menu with escape. Yeah, so that is pretty much the plan. I will be uploading videos on this project when I make some significant progress, like finish a section, and see ya!